Welcome to the next seminar in the FBA series, where we're exploring the Fellows' careers to date and some of the FBA projects. We hope that you're enjoying this series so far. If you're not already a member, you can join us at fba.org.uk/membership. As well as a number of other benefits, you'll receive priority notification for up and coming webinars and help support our valuable work in freshwater conservation. I'd like to hand you over to Dr. Allan Pentecost. Allan is an algal taxonomist and author. He's interested in the changes in algal flora in response to climate and stress.
So I'm just going to say a little bit about some work I've been doing over a good number of years, I suppose, but not really very seriously until this year. So most of the stuff I'm going to show you, which is going to take about 25 minutes, 30 minutes, there's been work that's been done in the last 6 months. So let's have a look then. So the aims of this project are really to look at the edge of Windermere. As you see from the aims, is to look at the extent of the rocky littoral. That's what I'm going to concentrate on today. Define some zones within that littoral. As you're well aware, around the seashore, there's a very well-defined littoral zonation. And the same applies to lakes, particularly rocky lakes. So I'm going to look at that. And look at the vegetation in this littoral at particular sites on the lake. And relate it to a number of things. Degree of immersion of the plants. I'm only talking about plants today. The exposure, the slope, and so on. And quite a few things could be done fairly simply. And finally, to use the information to perhaps set up some monitoring points for future work. Most of the vegetation I'm going to talk about today is not algae, in fact, although I have looked at algae on these sites. It's mainly bryophytes and lichens, mainly because they're the major organisms present in this zone. Some of them are very sensitive indicators of environmental change, so it's quite a useful thing to do for Windermere, understandably, in these times. So first of all, I'll just say what's been known about this aspect of Windermere before. Very little, in fact. Maud Godward investigated the littoral algae from the rocky shore of Windermere in the late 1930s and published the paper. You can see the title on the left there. She did a very good job, in fact, described a number of new algae. And also, more importantly, perhaps, she looked at the ecology of these algae to a depth of about 8 or 9 meters, which is quite something at that period. This was while the FBA was based at Ray Castle, and indeed the work was carried out quite on the shore below Ray Castle. But since that time, there's been very little. We do know quite a lot about the macrophytes of Windermere on soft sediments, and they're continuously monitored. They're looked at every year. So there's quite a lot of work known about those, but there's very little known about the rocky littoral. On the right there, you can see a couple of plants which are not part of the rocky littoral, but they're quite well-known plants from around Windermere. You've got impatiens there and Serratula. They're both local plants, actually, very attractive things that live around the shore of Windermere. So quite a lot is known, in fact, if you go a little bit inland around Windermere, off the rocky littoral, into the small wet hinterland, if you like, just behind. We do know quite a lot about the flora of the area. But the rocky littoral itself, very little is known. So before talking about the natural composition of the littoral, it's important, I think, just to mention briefly the geology of the rocks around Windermere. On the left, you can see there a simplified map of the lake, you should recognize there, and the major rock types that occur around it. The rocks actually are younging from north to south. So the oldest rocks are at the top of Windermere around Ambleside. They're volcanic rocks, and they are superseded by a thin layer of limestone known as the dent group. So they're highly calcareous rocks. They're not limestones in the strict sense of the word. They're about 50% carbonate, something like that. But they do actually influence the flora quite significantly. You'll notice the limestone slightly displaced on Windermere, and that's due to a slip fault that extends a fair way down the lake. And geologists believe that that's partly the reason why we have a lake where it is, because any faulting, of course, weakens the rocks and allows water to flow rather more easily. So it's more than likely that that particular fault has been responsible, certainly for the North Basin of Windermere being where it is. Anyway, below the limestone, which is only a thin band, we have a large area of what are called Windermere supergroup rocks. A bit of a mouthful, I know. They are deep sea sediments, or fairly deep sea sediments, and they're fine grained, but they are quite variable in their hardness and lithology. They're slightly calcareous, but locally they're extremely hard and resistant. They form rocks known as greywackies. You can see, I think, also there's some major folding in those rocks. The lines going across with the crosses indicate major fold axes on the geological map. And this was caused after this is the Silurian period that the rocks were laid down. Soon after that, there was an intense period of mountain building in the lakes. And the pressure has folded those rocks actually parallel to the slight dip of the rocks. And you can see that actually quite clearly, I think, in the next, same slide, but next further on. Let's have a look here. If you look there, you can see this is a LiDAR picture of part of the Windermere shore, and you can see quite clearly the undulations in the rock, the folding there as it comes up onto the edge of Windermere. So it's quite a varied shoreline, and certainly fairly rocky in places. The rocks themselves, I've mapped where the rocks are on the shore of the lake, and on this slide you can see Windermere split in half. Basically, you've got north and south basins there. The thickened bits, you should be able to see along the edge of the lake, are where the rocks are. And you can see in the North Basin, it's not particularly rocky. Most of the shore is boulder clay, certainly strewn with quite big boulders in places, but there aren't any outcrops in many parts. Up towards the top, where the volcanic rock side is fairly rocky. And indeed, the limestone band I told you about is also represented up there by rocky shores. Around the FBA, where the old FBA was, I don't mean Ray, I mean the one we just left, there's a little bit of rock there, but not very much, as you can see. If you proceed to the South Basin, you can see it gets much more rocky. This is clearly due, in part, I think, to the prevalence of greywackies, these very resistant rocks that tend to stick out on the shore. Quite obviously. If you look at the statistics, overall, about 50% of the littoral of Windermere is rocky. The rest is, say, boulder clay and so on. And you can divide, also do the statistics for north-south basins on the west and east side and so on. To some extent, of course, this dictated where I could sample. And one had to be a lot more choosy, for example, on the North Basin east shore than on the South Basin west shore. So what was the method? How was this done, the method? Well, I got a minimum of 12 sites to look at, to include both basins, with a range of exposures and aspects. I'm using unbroken surfaces where possible. In other words, they're cliffs that descend into the water without too many breaks or irregularities in them. Also, obviously, they've got to be safe to examine, which actually does cut out quite a few cliffs because the water is just too deep below them. I've used a quadrat method. A quadrat of fixed area is used, and I'm using it from -30 to +150 centimeters. Now, the datum I'm using is the mean lake level. We're very fortunate in Windermere in having a device that measures the level of the lake every day, and this has been done for several decades. So some very useful information there on lake level, which I've employed to set my datum. I'll say a little bit more about that on the next slide. The aim then is to record all rock vegetation, algae, bryophytes, and lichens, and with an estimate of percentage cover within these quadrats. Now, I've kept the quadrats the same area, 0.075 square meters, but and what I've done, I've used them at 15 centimeter interval above and below the data. And I keep these fixed. So for that reason, the quadrats actually change in shape a little bit according to the slope. Where I've got a vertical slope, which is quite rare, then my quadrat actually is 15 centimeters high, wide if you like. But where it starts sloping, the quadrat changes shape a bit just to keep the area the same for a particular height. That means I can compare different parts of the lake at different heights to see what vegetation they've got. So here's 5 years of data, 2016 to 2020, of lake level in Windermere. It's I haven't tested it for normality, but it looks like a normal curve to me. What I've done here is I've marked off, see with 2 arrows there. The lower arrow cuts off 2.5% of the area of that histogram to the left, and the right angle, it cuts off 2.5% to the right. Within the 2 arrows, I've defined that as what's known as the Littoral of Windermere, which more or less fits in with what the earlier limnologists call the littoral of the lake. There are quite a few terms connected with the littoral and where they're defined and so on. But it's quite rare to actually be able to put figures on them. We can on Windermere, which is actually very useful. So you see a strongly skewed curve there. The mean, which is at 39.65 or 6, I can't see it on the right at the moment, but you might better read it there, is very much to the left of the median here, so being a skewed curve. But those 2 points do actually allow me to define anywhere I am on the shore where the littoral is. Let's go back to that slide. I didn't tell you about the marker on the right. This is the device that's used. It's actually situated on Ferry Nab, and it's a vertical rule which is measured every day for lake level. And it's an interesting rule because the measurement's actually in metric feet, which is, I think, quite unusual. But so we have data going back many, many years. But I've just chosen the previous 5 years to use as a method to get the 0 point, if you like, or the mean lake level. So the zones are defined, therefore, in Windermere, for my purpose anyway, are defined by that percentile range, 2.5% cutting off the curve at each side. And it goes from plus 0.7 to minus 0.31 meters. That's keeping the mean lake level of Windermere as 0, local datum. So I take measurements within that region, and I define that as the littoral. The supralittoral, which again has its counterpart in the marine environment, I take above that. In other words, it's plus 0.7, and it goes up to 1.37 meters, which is the maximum water level which was determined during those 5 years. I think is probably a reasonable estimate of what it would be most years, or most 5-year periods. I mean, very occasionally it's gone higher. That's pretty much the area that gets wetted, at least occasionally. And the terrestrial zone is simply defined as the area above that, which I haven't spent so much time looking at. But I'm just going to show you a couple of examples of the profiles I've obtained from Windermere. This is from the North Basin, and it's a rock outcrop waterhead right at the north of the lake. It's on volcanic rocks. There are quite a lot of things there on the rocks, and I'm certainly not going to tell you about all of them. There'd be no point in that. I'm just going to concentrate on 1 or 2 for you. But you can see quite clearly there's a well-defined zonation. And on the right there, you've got the height above the local datum, the mean lake level. And the littoral zone is defined by 2 red bars, 0.31 below and about 0.7 above. And you can see within that zone, there are quite a few things growing. The most significant plant growing in that zone is a moss called Zinclidotus fontanelloides. And that forms a well-defined band around a lot of Windermere, in fact. If you look at the picture, you can see anything of the picture on the right. You'll see the dark lower patch, that's Zinclidotus. There's a slightly lower, lighter patch above it, which is an interesting little moss. It's called Pterygonium gracile, which is actually quite local in Windermere, and I'm not saying any more about it. Zinclidotus, however, is quite an important member of the community. The other members on this slide are either lichens or algae. I put in some the oscillatorias, the blue-green algae are there, but I'm not going to say much about algae today. really want to concentrate on just a couple of things. The other thing I'm going to mention to you is Dermatocarpon luridum, which is rather a large leafy lichen. And you can see that it more or less co-occurs with the Synclidotus. It's fairly low on the shore. It doesn't really go below mean lake level, however. It doesn't seem to on this slide. This is Synclidotus fontanelloides. That's what's called a Pleurocopus Moss. So it's very abundant and it's very strongly attached actually to the rocks. If you look on the left, you can see a couple of capsules. They are brownish objects. They look like nuts, and they're just creeping out on the stems of the moss. And this is a characteristic feature of Synclidotus, that the capsules are, if you like, pushed in against the leaves. Whereas for many bryophytes, they stick out on long setae, but not in this case. It's an interesting moss, and getting the leaves under the microscope actually reveals a wealth of other organisms. Algae particularly, but also you get tardigrades and all kinds of other things in there. So it's actually a little community on its own, which hasn't really been looked at, as far as I know, in Windermere. This is another transect, and this one, again, it's from the North Basin. It's from Bass Rock, which is on the east side of Windermere. It's, I suppose, about, I don't know, half a mile, a bit more, perhaps south of Ray. It's not an area that Gobbard looked at. It's, as you can see, it's quite a steep piece of rock by the profile, and it goes up actually into the terrestrial zone. Again, if you look at Synclidotus, it's not as well represented here as it was in the last area, but it occupies a very similar level. There's also another moss here, which is often regarded as a true aquatic moss called Fontanelis antipyretica, and it's just a little bit lower than Synclidotus. It's actually very close to mean water level. Again, the oscillatorias are present, as you can see, above and below water at the edge, with another blue-green called Tolipothrix, which occurs further up. And the Synclidotus is there. And if you look, there's also Dermatocarpon luridum, that rather leathery, quite interesting looking lichen. Is not well represented, but it's still there, and it's sitting in with the Synclidotus. As you go higher up the rock face, you get some semi-terrestrial lichens. Porphyria rugosa is a fairly well-known lichen of damp rocks. It's not an aquatic. It really likes seepage conditions. I suspect there is a little bit of seepage coming down this rock face at times. So it's not really a member of the aquatic community, although it does penetrate the Littoral. That's the thing called Xanthopalmelia. Quite interesting because it's a lichen we know that tends to grow where there's eutrophication. So somewhere above there must be a source of enrichment. What it is, I'm not sure at all. And above that still, we've got two mosses. We've got Rhacomitrium, which is a well-known other seepage moss, really often occurs with Porphyria. And at the very top, really a moss that's regarded as terrestrial rather than littoral, Hypnum resupinatum. But in this case, it's actually well within the eulittoral zone. So it's certainly not acting as a terrestrial there. I didn't follow it up any further, this rock face, because I was stretching my legs as far as they would. So I was standing in minus 40 centimeters of water at the time, and I just couldn't reach up any further to place the quadrat. So that's as far up as I could get. But as I said, I'm not really too interested in the terrestrial zone. So this is the kind of work I'm doing, and I'm repeating this for 12 sites around the lake. And I think it should yield some quite useful results, because none of these things you can see on the slide we know much about as far as their ecology is concerned. Most of them, in fact, haven't been recorded from Windermere. This is Dermatocarpon luridum, the lichen I mentioned to you. It's a very distinctive thing. Those of you who ever visit the lake, if you find a rocky bit of the lake, you can almost invariably find it if you look near the water level. And it's quite an interesting lichen. It's fairly well distributed within Cumbria, in lakes. It will only grow in the more mesotrophic lakes. You don't find it in the oligotrophic lakes like Phosphorous. It's just not there. So there's something about water quality also that's influencing the growth of this lichen. It's not just a matter of where it grows around the lake. It's more than that. It's reflecting the chemistry of the water as well to some extent, although we don't know at the moment exactly what the limits are of this thing. Although, in fact, in Cumbria, we have a lot of data on this lichen now. Through the FBA and its archives, of course, we know a lot about the chemistry of the waters of the lakes. So it's simply a matter, I think, of someone putting the two together and see what comes out. I think it could be quite interesting. It's not a rarity at all, but it's definitely a member of the Windermere community that's, I think, probably been neglected really in the past. You can do quite a lot with this data, and I say it's quite an early stage within this study, so I can't show you much more, but what you can do, the sort of information I've gathered, you can look at any of these plants, and I've chosen Cinclidotus because I've mentioned it to you before. I've shown its relative abundance on the right there, on the ordinate, and I've just combined all the data I have at the moment on it, which is not very great. It's more than you've seen, but it's not a huge amount. But I've looked at the relative amount, and I've plotted it against the period of exposure on the shore of Windermere. Of course, it's possible to do that with that histogram I showed you. It's possible to look at any slice height up the lake and work out quite easily how long the lake is up there and how long it's not. And you can see with Cinclidotus, it actually maximizes about 80% exposure. So it's not actually underwater very much, which is probably in keeping with most mosses. They don't like being underwater too much. But again, this is information we didn't have before. It's quite interesting because if you remember when I showed you the picture of Cinclidotus, it had sporophytes on it. Now, these are the structures by which the moss reproduces sexually, so it's quite important to it. Now, the sporophytes need to be out of water, and most mosses reproduce in the spring. And if you look at this plot of the mean lake level of Windermere, again, it's during the data for 2016 to 20. This time it's done month by month. You can see how the lake generally is quite low during April, May, and June, and at its lowest, in fact. This is the very period when Cinclidotus fruits or reproduces. So it's clear within its interest to be fruiting at a time when the lake level is low. So what I haven't mentioned to you, of course, is water splash, which is I don't want to talk about that today, and wave action, which is clearly important in Windermere. That's really, I think, for another day. But it's putting together and it's making a story which I think is could turn out to be quite interesting. Before I finish, I'm just going to show you a picture of some lichens which you probably don't know, but they're actually quite important. These are two Schedule 8 red data lichens that occur in the Littoral of Windermere. These are threatened species, and they're of some importance. There are two of them, Endocarpena descendens on the left there, and then there's Collima dichotomum, sometimes known as the river jelly lichen on the right. Now these are actually quite important in a way because they are extremely rare in this country, and Windermere is one of the few places you can see them. One of them has turned up in one of my quadrats, that's the Endocarpena. It's turned up at one spot. The Collima, interestingly enough, it tends to be associated with that line of limestone I showed you on the geology slide at the top, the Coniston limestone, as it used to be called. And that's where the Collima is found. But it's very local. And just recently, another rarity has turned up in Windermere, funny enough, in one of the quadrats, which has only got one other station in Britain. So there are very interesting things in Windermere that I think we need to know about and publicise a bit more. Right, well, that finishes my talk. I'd hoped it would take half an hour. It's taken a bit less, but I hope you found it of interest. And maybe I'll be able to inform you a bit later on of how the study's progressing. Thank you.
Thank you very much, Allan. Has anybody got any questions that you'd like before we wrap up? Hi, Suzanne. What's your question?
That was great, Allan. That was a really, really interesting talk. And there's been a lot of stuff, larger lakes on Baikal and things at the moment, looking at changes in littoral communities and how they're kind of leading indicators of eutrophication. So I think this is really really topical, in terms of large lakes and impacts. I wanted to ask about that old paper that you mentioned at the beginning. Have you had a chance to make any comparisons between what you're seeing and whether there are likely to be any changes from some of the older records, or is it of a quality that you can, is the data set of quality that you can compare the past records with yours?
Yes, you can. I have looked through the paper, and when Liz and I were doing our algal flora of Cumbria, we had to consult it. And quite a few of the things she found actually are still there. But I've only seen them in different parts of the lake, not the bit she looked at. So I don't think probably there are that many changes, interestingly enough. You might expect some, wouldn't you, when you read about the phytoplankton and the changes that's gone through. But we haven't looked at it in sufficient detail. And I didn't mention algae in the talk because I just wanted to concentrate on a few of the other things. But I am monitoring those. And I think when the thing gets a bit further on, we have a better idea, particularly when I take a couple of sites near where Godwood was taking them to see. I think then we'll get some better ideas what's going on there. So there could be changes, and I think we just have to wait and see.
Fabulous, thanks.
Alan, can I ask a question? Dave John, can you hear me?
Yes.
Was there much seasonality in the algae? I know you've been talking about lichens and you've been talking about bryophytes, but I know you did mention some of the algae there, but I've noticed, for example, Eulothrix zonata, which tends to be common in the spring. Did you find that at other times of the year as well?
That's in the lake now, I think, and it was certainly in the lake when I did that transect 6 weeks ago.
Okay.
Yes. So it's actually, I know what you mean, David. It's much more obvious in the spring, Eulothrix, isn't it?
Yeah,
forms a sort of band,
streams and rivers, isn't it? I mean, yes. That's what I tend to find.
Yeah. I think it's pretty much all around the North Basin, at least. Okay. Yes. I mean, it's very obvious in the spring. I think Liz might confirm. But yeah, it's still there. Often you get it with Cladophora, but funnily enough, I haven't come across Cladophora yet in these transects. So I expect it will be around. But yeah, so it's quite late, really. That's right.
Okay. No, I'm just interested.
Yeah. Thanks for your question.
Is there any other questions?
I almost was meant to ask you, did you find the lake bulls at Agrobactyla actually at all? I think they've been recorded in Windermere, but whether they'd be attached on a littoral is another matter.
No, I haven't seen them yet.
Okay.
No, I do keep an eye out for things. But, one thing that did turn up, which was recorded in the lakes, I think 40 or 50 years ago, and has not been seen since, and that was actually on the Synclidotus, was a thing called Desmonema wrangeli, which is a peculiar blue-green alga. Wow. Which, according to our records, has not been seen for a long time. And that was a surprise. It's nice to see. Just a bit of serendipity, really, I think. Turned up.
I noticed you had Tolipothrix there, which...
Yes, that's common in Windermere.
Yeah, well, I found it mostly in the Midland Lakes in Ireland, actually, Malingar area. It's very, very common, exactly in that sort of area, in the very shallows, which I could imagine become part of the littoral at certain times of the year.
Yeah, I think it's quite an important alga in the littoral, actually, there in Windermere. Yeah.
Alan, you talked about potential monitoring in the future. Are there any thoughts about how you might organise that?
I suppose I'm just being optimistic that when it gets published, we hope it gets published fairly soon, that people will, if the sites obviously will be placed there, and nowadays with the sort of accuracy we've got with GPS, people will be, if they want to, they can go and they can say exactly how it's changed. Whether they will, of course, we don't know. But I think it's important to lay down some groundwork. So if people want to see what's going on there, they can go back and refer to it and know exactly where the quadrats sites were taken. I should imagine it might be a useful thing to do in a few decades. Who knows? I mean, if the lake really gets bad, then obviously it can be soon. Yeah.
I think it'd be brilliant, and so it's there as a baseline for comparison in the future. In that context, are you archiving the samples or some of the samples, or are you just doing field ID?
I have archived the algal scrapes, because they don't take up much room. No, not the other things, unless they're things that are new to the site. If they're new to Windermere, I keep a reference sample. But otherwise, I don't archive the actual material. I suppose it could be quite useful, couldn't it, to actually take a few samples of these bryophytes just for reference, in case anyone wants to look at trace elements or trace pollutants. So yes, that's not a bad idea, actually. That could easily be done.
And amazing what interests and techniques actually emerge as time goes by, isn't it?
Yes, I can see the point of doing that. And of course, bryophytes, as you know, very easy to preserve. Well, lichens are too. You just dry them and forget about them effectively. Yes, perhaps they could come into an FBA archive. That's a good point. Thank you.
Hi, Alan. I'll put my hand down now. I can work out how to.
Sorry.
No, there we go. Really interesting talk. One tiny wee bit of feedback from a marine perspective. When we talk about exposure, we mean wave exposure. So it might be worth talking about cycles of immersion and immersion for clarity. Just a little point there. And also, you mentioned Maud Godward's work. Did she look at other lakes other than Windermere, or was it just focused on Windermere?
I think she looked a little at Oswaldshire. I think not really. No, it was concentrated on. It was a PhD, and she concentrated on that lake. I think there's a little bit of information from elsewhere, but not a lot. I recall. And certainly not anything that's very useful.
Is that publication available online yet, or is that just through the
I should imagine it would be. It's in Journal of Ecology.
Okay.
One of the early journals of ecology, volume 8, I think, something like that. So, yes, I'm sure it'd be easy to access that. Yes.
Yeah, I think that sort of work would really make an excellent dissertation project. So
I think it would. Yes.
Yeah. Maybe we can talk about that
right.
with this meeting. Yeah. Cool. Thank you.
You're welcome.
Yeah, well, I'm happy to ask a question. I was, after what Rick was mentioning about monitoring, have you looked at any other lakes, or are you intending to look at other lakes? Because
in that way, you mean?
Yeah, in the same.
Not in that way, but I have looked at 2 or 3 other tarns for the blue-green, littoral blue-greens. That was a slightly different study. Not with the thought of actually monitoring them. More often the idea of just simply knowing what's there and where it is. So we do know a little bit about them. There's a lot of scattered data around. There's a huge amount, of bits and bobs, so to speak, little notes and comments, but not much detailed work that I recall. Not on the littoral anyway.
No. Because I know quite a lot was gained from comparing the lakes and their different chemistries.
Yes.
And this sort of work, it's the basis of the work that, the environmental monitoring work. This is the sort of data that, that it stands on. And the littoral is probably a lot easier to monitor than going into the water.
That's very true.
From a practical point of view. So,
yeah, I don't need to carry a boat around with me.
No.
That's right. It is, yes. Except if the water's deep. And the trouble with Windermere is there are parts of it where it actually shelves very deeply. It's quite surprisingly deeply. I think Maud Godward actually mentions one of her sites, which is over near Ray. It was a steep slope that disappeared down into 100 feet of water straight away. Which I certainly avoid that one.
Yeah.
Not being a very good swimmer, I keep that out.
No.
Just pursuing that a little bit, Alan, thinking about sampling, you're essentially sampling plants or bryophytes, lichens that are growing on the rock. There are algae associated with them, but there also be algae growing directly on the rock surface.
Sure. I've looked at both. I take scrapings of the rock, and I just monitor the mosses. I don't quantify the stuff on the moss, but I just see what's there. One of the surprising things is that diatoms are really rare. Hardly ever see a diatom, even minus 30 above average, below the average level of Windermere.
Right.
Found very few diatoms, which is surprising. I've done this in the summer. Maybe it'd be different in the autumn.
You probably need to be deeper in the water where the rock surface never really dries out. Maybe that might be the problem there. Although there is a group of diatoms that, of course, will grow on in semi-terrestrial conditions.
Yes, there are, aren't there? Yes, I was very surprised that I wasn't finding them. I mean, I've done 5 of those transects so far. I'm going to do 12. I mean, it'd be interesting to see, but it's a regular thing. You know, I just can't find them, or very, very few. It did surprise me. I was hoping to get Liz to join in, do some identifications.
Suzanne, you've got a question?
Yeah, I just wondered about water level regulation. I feel like I should know the answer to this, but are the water levels regulated in Windermere, and has that changed through time?
There is a scheme whereby they can be regulated. Yes, in terms of drought, there is a pumping scheme that can be employed to remove water, but I think it requires quite strict conditions. I don't think it doesn't happen at all regularly. But yes, there are. I think it's a rare phenomenon, though, as far as I'm aware.
So you think that's quite a natural, the fluctuations that you've measured?
The fluctuations you see there is pretty much, the fluctuations of a lake, I think, yes.
Okay. Interesting, thanks.
It's useful to have that data set, because I think potentially it's very useful for other things as well, having that lake level data,
sure.
All kinds of things.
Thank you very much, Allan. Thank you very much for joining us. I hope everyone's enjoyed it, and that we can see you again at the next one.
Yeah, thanks for your patience, everyone.
Thanks, Allan.
Cheers. Bye.